Hello viewers, I am Sumit, Assistant Professor of Mallam Institute of Technology in Mechanical Engineering Department. Now I want to represent the basics of internal combustion engine and gas turbine. Here the outline of the presentation. First of all, classification of engine terminologies, difference between the petrol engine and diesel engine, difference between the two-stroke, four-stroke engine, as well as their efficiencies, gas turbine and Brayton cycles, and their applications. Now, in introduction, in 1876, four-stroke engine based on Otto cycle was first developed by German engineer Nicholas Otto, as well as diesel engine also developed by Rudolf Diesel in 1892. In IC engine, basically chemical energy of the fuel that is converted into heat or heat energy, that heat energy converted to the mechanical work or mechanical energy. First of all, in IC engine, that different set in IC engine and EC engine. Basically combustion according to their combustion, IC engine and EC engine. IC engine basically internal combustion engine and external combustion engine. When the combustion takes place inside the cylinder, that is internal combustion engine. When the combustion takes place outside the cylinder, that is external combustion engine. Due to inside combustion of the cylinder, IC engine size is compact and more efficient. Obviously heat loss is less, but for external combustion engine heat loss is more, as well as larger size is required. Here costly fuel are required for IC engine like petrol, diesel, but in external combustion cheap fuel are used like coal, more suitable for mobile application, but in external combustion it is less suitable for mobile application. Now the classification of IC engine. IC engine can be classified in different phenomena. First of all, petrol engine, diesel engine, gas engine. Now compression ignition engine, spark ignition engine, all different componental phenomena as well as application phenomena. There are different design condition also available. We can see that in inline engine, where piston movement takes place and all that shaft are connected in inline, and in V engine the shape of the piston movement as well as shaft connection, the in V shape, and opposite engine in opposite side piston movement takes place, in middle shaft rotation takes place. Now engine details. Engine details is basically, first of all, spark plug that located on the top of the crankcase, where and in either side of the spark plug exhaust valve and inlet valve takes place, and in the bottom there is crankcase. That is in that crankcase there piston crankshaft rotated and connecting rod also, that piston movement that help on through the connecting rod. In middle combustion cylinder located. Now engine terminologies. First of all, it is movement of the piston on the top side and bottom side. At the top point of the cylinder, that is called TDC, and the bottom point of the piston movement, that is BDC or bottom dead center. Up to that, the cylinder volume, that is called stroke volume. Now Otto four-stroke cycle, that whole the process takes place in 4 process. We can represent in the PV diagram, where A to B, that is compression, where isentropic process adiabatically takes place, then B to C, that is heat addition process. The main difference between Otto and diesel cycle is the heat addition process. In diesel cycle, heat addition takes place in constant pressure process. Then C to D is the expansion adiabatic process, that is also isentropic or adiabatic process. Then D to A, the heat rejection process, where it takes place in constant volume. All that processes takes place in different strokes, namely suction stroke, compression stroke, power stroke and exhaust stroke. First of all, intake or suction stroke, where inlet of the air fuel mixture for the petrol engine takes place through the inlet valve in the engine cylinder. Then that piston movement from BDC to TDC, that is compression, takes place. After that compression, ignition and combustion takes place. For that combustion, piston comes down to BDC, and for that process power we can get, and for that power crankshaft rotated and ultimately shaft rotation takes place. After that process, exhaust process, where piston movement from BDC to TDC and burned fuel that exit through the exhaust valve. Now hold the process and corresponding valve opening, that is in suction stroke. During suction stroke, inlet valve remain open and exhaust valve remain closed. After that compression, both the valve remain closed. After that ignition, where also both the valve remain closed. After that exhaust, where inlet valve remain closed but exhaust valve remain open. Now diesel 4-stroke engine, that is the main difference between the Otto cycle and diesel cycle. As I said earlier, that A to B, that is compression, but heat addition process, that is B to C, that takes place at constant pressure process. Then C to D at expansion process, isentropic or isentropic process. Then D to A, heat rejection, takes place at constant volume process. Now all the strokes as the petrol engine as showing in the slide, but main difference is that for diesel cycle, here in inlet valve only air can admitted to the cylinder, but in petrol engine both air fuel mixture admitted in the cylinder. During combustion, here fuel injected in the cylinder. This is the main difference, where diesel engine heat addition takes place at constant pressure. Either after all the process same as petrol engine. Working of the 4-stroke engine. 4-stroke engine basically, as we say, as I say that 4-stroke basically piston movement, that TDC to BDC, all the process movement of the piston, that is called 1-stroke. Here air intake takes place in, or the suction, that is 1-stroke. Then compression, then fuel injection and combustion, then exhaust. Here in slides you can see that air inlet path also showing, then fuel injection nozzle path also showing, and exhaust path also showing, all the components of the 4-stroke engine. Now the difference between the petrol engine and diesel engine. Basically petrol engine works on the Otto cycle, diesel engine works on the diesel cycle. Petrol is used as a fuel in petrol engine, diesel is used as a fuel in diesel engine. Compression ratio is less for petrol engine, for diesel engine compression ratio is more. Thermal efficiency is lower due to lower compression ratio, but in diesel engine thermal efficiency is more. maintenance cost is less for petrol engine, but in diesel engine maintenance cost is higher. Another main difference is easier starting of the petrol engine takes place because of having spark plug, but in diesel engine in cold condition difficult to start. Running cost is higher for the petrol engine, but in diesel engine running cost is lower or cheaper. Now two stroke engine, nothing but like four stroke engine. In two stroke engine all the processes completed in two stroke only. Here we can see clearly that piston movement from BDC to TDC, two process takes place, that is fuel air fuel mixture admission as well as combustion. After that TDC to BDC power stroke and exhaust takes place. So only two stroke only whole the cycle can complete it. That's why this cycle is named two stroke engine. Now difference between the two stroke engine and four stroke engine. Four piston stroke required to complete the one cycle for the four stroke engine, but for the two stroke engine only two piston stroke required to complete the one cycle, equal to half of the speed of the engine crankshaft. Number of power stroke equal to n equal to capital N by 2. Capital is the RPM. Basically in four stroke engine whole four stroke only corresponding to alternative revolution we can get power, but in two stroke engine every cycle revolution we can get power. That's why small n equal to capital N for the two stroke engine. In inlet and exhaust valve are required for the four stroke engine, but in two stroke engine valve, in terms of valve, ports are required to complete the process, or during motion condition, motion engine in running condition, ports are open and close. That works in four stroke engine, valves are necessary. Thermal efficiency is higher for the four stroke engine. In two stroke engine thermal efficiency is less. Mechanical efficiency is low because more number of moving parts in four stroke engine, but in two stroke engine mechanical efficiency high because of less number of moving parts. Basically this engine means four stroke engine is used for higher power application, that means car, truck, tractor, but in two stroke engine used in scooter, motorcycle, mopeds, etc. Now gas turbine or Brayton cycle, that basically works on Brayton cycle gas turbine. There is nothing but difference between the internal combustion engine or gas turbine. Here the main difference is here working fluid, that is basically air, is used. Here in the graph we can see that fresh air is admitted to the compressor, then compressed air is go through the combustion chamber, and in the combustion chamber fuel also ignited, and after the combustion the pressure of the gas increases. Due to that gas pressure working takes place, or turbine rotation takes place, and work we can get. After that exhaust process also takes place. Now in the graph here 1 to 2, that is constant entropy process or asymptotic process, 2 to 3 constant pressure process or heat addition, constant pressure heat addition process, 3 to 4 power isentropic, power stroke or power isentropic process where you can get power under turbine. Then 3 to 1 heat rejection or exhaust takes place. Corresponding TS diagram we can see. Now the types of gas turbine. There are jet engine, turboprop engine, aeroderivative gas turbine, amateur gas turbine, auxiliary power unit, industrial gas turbine and power generation, compressed air energy storage, turboshaft engine, radial gas turbine, scale jet engine. All different types of gas turbine according to their application phenomena uses. Now the one application, that is marine application. Gas turbine used in the naval marine vessel where they are valued for their high power to weight ratio and their ships resultant acceleration ability to get underway quickly. The first gas turbine powered naval vessel was Royal Navy's motor gun boat MGB 2009. This is one application of the gas turbine. So all the basics of the gas turbine as well as engine. So thank you for seeing this video.